If n factorial ends with 29 number of zeros and n is even, then how many values of n are possible? Now, first of all, we need to check that all factorials, all number of zero at end is not possible. Why it is? If I check 120, 120 factorial, and if I check 125 factorial, I can see the number of zero, how it is changing. As 125 is 5 cube, so it is nothing but 3 extra 5 it appear. I'm opening it up, just trying to explain. 120 factorial, it is 120 factorial, 120 by 5, so it is coming as 24 by 5, so it is 4, and I cannot further divide. That means I can say one thing, that 120 factorial, 120 factorial ends with 28 zeros, and 120 onwards up to 124 factorial all ends with 28 zeros. Now 121, 122, 123 and 124 all factorial ends with 28 zeros. That remains same. But whenever I am returning to 125 factorial, as it is 5 cube, 125 itself after 124, next data 125 itself is 5 cube, I can see 125 by 5 is 25 by 5, is 5 by 5 is 1. And in this case, I will be able to find 25 plus 5 plus 1. So the next possibility after 124 factorial, I can see that this one is nothing but 31 number of zeros. So 125 factorial ends with 31 zeros. So very interesting thing I have seen here, that 28 zeros, 120 factorial till 124 factorial. But next one, 125 factorial, it is 31 number of zeros. So 28 to 31, any zeros are not possible. And here it is 29 zeros. So it is actually not possible. So how many such natural numbers, it is the question. Even, odd, whatever it may be, that is not at all possible. So none of these would be my answer for the question.